Hi guys, Chris here. Many of you might remember the video that I made quite a while back where I set up the LongMill vertically to see how it could perform in that orientation. At the time we were launching our machine on Kickstarter and we were getting quite a handful of questions asking about the rigidity of the machine and also if it was feasible to set it up in a vertical orientation. I figured I might as well kill two birds with one stone, and so I decided one night I would set the machine up, bolt it in place using two tables, and see what the result would be. And I was very happy to see that the machine was able to continue to perform as I expected it to in the vertical orientation. Fast forward to now, people will see this video and I will occasionally get questions asking how they should go about setting their machine up in a vertical orientation after they've purchased the LongMill from us. And after hearing the success stories from a handful of our customers who have set up their LongMill vertically and have been able to run it for months and months and months with great results, I've decided to take another stab at designing a more official vertical mount for our LongMill CNC machine. I went for a standalone design because this allowed for the machine to be mounted onto the stand while the stand was laying flat on the floor. And once the aligning process was completed, I was able to lift the stand up and stand it up vertically and now have the machine ready to go. The other important thing I wanted to consider in my design is an ability to support raw material, which may be on the larger side, while you're trying to mount it in place for a cutting operation. And this is where my adjustable height shelf comes into play. Now this shelf uses just some scrap material I had lying around, and by cutting the two alignment rails on the CNC itself, it ensures that the hole placement is quite parallel. And by leveraging two 1/4-inch steel dowel pins as well as some threaded inserts, I'm able to adjust the height of this shelf and mount it securely in place. And that then acts as a sturdy surface for me to rest material on while I'm clamping it or screwing it or gluing it in place on the machine's waste board. Now I'll post plans to this design, both the 3D model and the drawing, in the description of this video, so you can check it out yourself. But in general, this design is able to be assembled completely out of a single sheet of 4x8 3/4-inch thick MDF, or two 4x4 foot sheets, as well as about 9 2x4s that are about 8 feet in length. Once again, the more precise measurements and lengths of all of these materials can be found in the description of this video. Now I had some great help from my cousin Victor in putting this entire stand together. It's very handy having a second set of hands to ensure that the lumber is square, that you're getting all the correct angles, and especially to lift the stand up onto its feet after it's done being put together. Once you've mounted and squared your machine and you've got the stand upright, this is the opportunity that you can take to use the shelf to your advantage, stick your last piece of spoil board MDF into place, and mount it to the surface. And once this is mounted, that's when you're going to run your surfacing operation to ensure that your spoil board is parallel to your router. I want to reiterate how important it is to be wearing respiratory protection and ear protection and eye protection while you're around your machine, especially when it's in an orientation like this. And especially in this case, since I wasn't running the machine with a dust boot on it, the MDF particles are very fine and you really don't want to be breathing them in. So between the time when I had set the machine up initially and when I had a chance to come back and complete this video, we actually expanded our office a little bit, so I had to quickly set it up in the new location. But it was quite simple to do. I just ran an extension cord to the control box that was mounted to the side of the stand, as well as rolled a laptop over so that I can control it. Now I figured it wouldn't be enough just to set the machine up in a vertical orientation and call it a day. Just like with my last video, I wanted to set out to make a project in the vertical orientation to test the machine's capabilities while it was at this drastic angle. And so this time I decided to go for a much more precise cutting job. I was looking through Thingiverse and I found a hilarious model of a really buff Pikachu and thought that it would be great to try cutting it out. Once I grabbed the model, my first objective was to manipulate it in a way that I could cut it out. I had a small block of wood on hand that I thought would be great, and so I wanted to size it out to see how I could fit this Pikachu model within the block of wood. I then moved over to Mesh Mixer, which is by Autodesk, and it's a free to download program, and started working from there. Now, as I say, my intention here is to get the model to fit inside the piece of wood that I want to use in a way that I think will look nice. And so the first set of operations was to split the model in half so that I could have it protruding out the front of the wood, and then split it again in order to get the rough proportions of width to height so that it would match the block of wood. The last step was to make sure that the model lay flat on the build plane, and this would make importing it into CAMLab much easier. This is a simple matter of just grabbing the model and rotating it to get it about to the right position. This doesn't have to be exceptionally accurate. Once this was done, I just exported the STL and then I was able to import it into CAMLab. When you're going through setup on CAMLab, you want to start on the top left-hand side and work your way down through all of the options until you reach the three main buttons at the bottom. And once you've reached those three main buttons, that's when you turn your gaze over to the right-hand side and you work your way down the right-hand side. That's when you're able to select the types of cutting that you want to be performing. And then you go back to the left-hand side where those three main buttons are, and that allows you to both visualize the cutting paths that you've selected, as well as export them to a G-code file. So what I'm doing first is I have gone to the machine at the top left and selected the LongMill, the 30 by 30 version. And then I've gone and I've hit the import button in order to import the Pikachu model into CAMLab. My next step is to pull out my calipers and measure the dimensions of the block of wood I'm going to be using, and I'm going to enter that into the material size window that's still quite high up on the left side in CAMLab. Once I've got the dimensions of this wood entered in, there will be a box that pops up in CAMLab that'll show me what the box size looks like. Now, based off the size of that box, I can see that the Pikachu is too large to actually fit into it. And so I scale down the Pikachu accordingly by first clicking on it so that it's highlighted green, and then going to the scale option, which is in the center of the bar, which appears at the bottom of the screen. And I'm just scaling it down by a small amount each time. So let's say I enter all of the values are at 1, so let's say I enter 0.99, then that'll scale it to be 99% the scale of what it was before I scaled it. And so I'm not being very accurate in terms of what the exact scale is that I want it to be. I'm more so trying to ensure that the model will fit inside of the block of wood, and I'm just doing that by visually looking from the top to see if it will fit, as I hope it will. If you do want the Pikachu or any of your 3D models to be hitting a specific size, and the model is currently a different size from the size that you'd like, then if you take the size that you want and divide it by the current size, you can get a scale factor. So let's say that the size that you want is 100 millimeters wide, and the model is currently 50 millimeters wide. Then you do 100 divided by 50, and you'll get 2. And so you enter 2 into the scale factor, and that'll scale your model up from being 50 millimeters to being 100 millimeters. If instead the model is currently 50 millimeters and you want it to be 25, then you take 25 and you divide it by 50, you'll get 0.5, and then you enter that in as your scale factor. It'll scale the model from being 50 millimeters wide to being 25 millimeters wide. Once I've completed the scaling operation, there's an option in the positioning tab that says snap to top. And what I do is I click that option and it'll essentially raise the model up to the highest that it can be while still being within that box, that material size box. And this will result in the bottom part of the wood block to remain after the carving has been completed. And this is going to achieve the look that I'm looking for, where it will kind of be a backing square with the model popping out of it. Now the next step is to locate my bit properly. You'll see that I've switched it over to a 1/4 inch bit because that's what I'm going to use for doing the initial material removal. And what I've also done is I've placed the bit at the center of the stock as well as at the bottom. Now the reason for doing this is for ease of my setup. Since I know the size of the block that I'm cutting, it's easy for me to bring the end mill to the center and locate it to start cutting. Now the reason that I've set the origin at the bottom as well is because the roughing is going to cut out most of the material around the model, and it's going to remove the top surface. So if I set my cutting origin at the top of the material, then that top surface is going to disappear after this first job. And after this, I want to be switching over to a more detail cutting bit. And so when I switch bits, my Z-axis location is going to change. So if my top surface is gone, then I no longer have a surface to reorient from. Whereas if I relocate from the bottom, the bed of the machine, then that's going to still be there after the roughing cut is complete. Now with all of this set up, I turn my gaze over to the right side and I check the roughing toolpath to open up that dialog box. The settings that I use are quite straightforward. The really important number here is the leave stock amount. Since I'm going to be roughing this out initially and then changing over to a more precise tapered bit, I want to be leaving a little bit of extra material on this roughing pass so that the finishing pass has some extra material to play with. This will ensure a really nice final result. And so this is what the leave stock amount is for. It's leaving a 1mm gap between what it cuts and what the final model actually is, so that when I do a second operation, I can clean up that final millimeter of material. Now I just generate this toolpath and it looks good to me, and so I export it and I save it as a name that I can remember, and then I move on to the next toolpath type. I've already saved this end mill, which is one that's available on our shop and will also soon be a default in CAMLab. I've just set it as a 1/2 millimeter radius ball nose bit in the end mill window, which you can open up and add a new end mill to. With this bit selected, I will uncheck the roughing toolpath type and check the relief toolpath type. And in here is where I'll set my settings for doing this finishing pass. Now I'm going to generate this toolpath and you can see the results of it. There's a lot of lines going back and forth across Pikachu in the x-axis, and you can also see the blue lines which indicate the movement of the bit between those toolpaths. The toolpaths are shown in black and the movements are shown in blue. So I'm quite satisfied with that as well, and so I'm going to export that cutting toolpath, save it as a file name that I'll remember, and send it on over to the machine. I need to set up my stock material. I'm just using a small strip of MDF, putting it between the feet of the machine in order to get that block of wood so that it's flat along the cutting axis of the machine. And then I'm just plugging in a hot glue gun and using some hot glue to stick it to the spoil board. This is a really easy way of attaching wood to your spoil board or other types of materials as well, as long as they're reasonably porous. Before using the probe to locate the bit, I'm using the raw probe leads as a test to see that contact is being made between the two contact points. Once I've confirmed that the probing cycle is working correctly, I can move on to actually locating the bit on the workpiece. I use the computer to jog the machine over to the general area where I'll be starting the probing. I've got my 1/4 inch bit in the router already. And so I bring the bit down the surface on the diagonal of the probing block, and then I activate an XY probe so that I can probe upside down, lay it against the spoil board, and I initiate a Z probe in order to touch off the height of the bit. Located off the corner here, but in CAMLab I told it that I'd be locating off the center. I need to actually and I double check the measurements of the height and width of the block, and then I send a movement command to the machine in order to make sure it's positioning itself right in the center of the block. And then that's where I reset my cutting origin, and I can finally start the cutting job. So as you can see here, I've just hit play, and the machine's already starting to hog out the cedar, and it's doing a really good job, and it's looking like it's quite well centered on the block, just how I would expect it to be. And this cutting procedure only took, I think, 6 minutes to do. The 1/4 inch bit makes very quick work of material removal. Especially, I will change later about this model to make it a little bit better, which I'll explain to you during the next cutting operation. But for the time being, you can see that I used a hacksaw to actually cut off the corners because I wanted it to be flush. Now you can see that I'm changing the bit over to the tapered bell nose bit, which is the one, as I mentioned previously, since I'm changing the bit over, I will need to reconfirm the Z-axis height of the bit. And so I just grab the probe, I flip it upside down, and I reinitiate a Z probing cycle. And now I'm back in position and ready to go, and I start the next cutting job. So with that now underway, I'll make some clarification here. Comparing the model, since the model, the full size of the stock, what I did is I went back and I added a square onto the back of it so that when it was doing the cutouts here, you can see initially it was just cutting out the shape of the model, but afterwards I went back and I cut out not just the shape but also the back plane of the model in order to make sure it was all flat to whatever setup that you're trying to do. But you can see that the detail that comes off the machine is quite nice, very detailed, very fine. You know, those abs are, you know, only a couple millimeters in size. Second finishing operation, the buff Pikachu was looking really nice, and so I just took it back to my desk and started cleaning it up. Contour cuts always need some finishing work after the fact due to the wood strands that try holding on to the underlying wood structure. Even though these can be pushed off just using a fingernail, I've tried a variety of methods from X-Acto knife to sanding sponge. One thing that I didn't have on hand, which I think would work best, is a bristle brush or a flat wheel that are very light so that they can get into all of the nooks and crannies of a small relief cut such as this one and make your job a lot easier when it comes time to clean up your relief. Here I'm showing the size of a business card for scale. The last step that I want to go to here is to protect the wood and also bring out the grain in the wood. So to do this quick and simple, I just grabbed some mineral oil and wiped it all over the completed carve. Now this was easier to do if you have paper towel or a shop towel. I didn't have either of those on hand, so I'm just using toilet paper and a generous amount of oil to ensure that it soaks into the grain in all areas. And I think this is kind of fitting as well because Pikachu's kind of looking like a bodybuilder here, and the bodybuilders are always oiling themselves up. In any case, I think it turned out really nicely. You can see that I just use some cloth in order to clean off the excess oil, and then the finished result is a carve that really pops, and it has a lot of detail, and you know, you never guess that it came off of a hobby CNC machine that was mounted vertically. So I'm just going to take the end of this video to point out this blog post that we posted on our website when I put up the original video. And this just makes some great points that talk about, even though you get the pro of a vertical setup in that it can reduce the amount of space a CNC will take up in your shop, this kind of goes over some of the cons that you might want to take into account when you're running a setup such as this. At the end of the day, the LongMill is a nice toy and a nice tool that we offer at a very reasonable price. And so I think if you want to experiment and set your machine up vertically, then I'd say go for it. I hope you had some fun with me throughout this video and learned some stuff along the way, and I'll see you in the next one. Bye guys.